the periodic functions, and we also saw the graph of these kind of functions, right? So if we multiply some constant to the trigonometric function, then what happens to that? Then what happens? Then its amplitude gets increased, right? So when you multiply the coefficient before the trigonometric function, so it's the amplitude of it that would only be increased, right? So let's say that I have right, I have this. Let's say I have this sine function, right? So let's say this is sine function, and then if I have this is sine function, right? And then 2 sin x would be just the upper one. So this would be 2 sin x. 3 sin x would go higher again, right? So this would be 3, this would be 2, and this would be 1. So if I multiply a constant before a trigonometric function, then period doesn't change, right? So the period remains the same. Is it clear, guys? Only the amplitude will change. This height will change, but the period will not change. Is it clear to you guys?
Yes, sir.
Yeah, and then what about this? Let's say if I take the example of sine of 2x. So now your function is 2x. Or let me write it as theta, right? Then what will happen to the period? So let's say if I plot these diagrams, so at theta, when it will become 1 now, right? When it will become 1 at let's say this is sine theta and this is sine of 2 theta. And let's say at 0. So at 0, this sine theta would be 0, this would be also 0. But what happens at let's say 45, right? Or this is pi by 4. This is pi by 4. At sine pi by 4, what is the value? What is the value of sine pi by 4? Yes, guys,
1/√2.
1 by root, right? So this is 1 by root 2. But what would be the value of sine 2 theta? What would be that, guys? What would be that?
Uh, Sine √2 theta.
So sine 2 and what
Sine
is the
root two.
where is no no no. So this is not the multiplication. You are multiplying on the angle.
Um,
Angle is being multiplied, right? Don't think that this is the other multiplication. So this is the whole angle, right? This is the whole angle that we are taking. So if I write sine 3 theta, sine 4 theta, so this is again the angle, right? So now what would be the value? That would be sine 90, so that would be 1. Sine 2 theta at pi by 4, that would be 1. Is it clear, guys?
yes, sir.
And add pi by 2, right? So let's say if I calculate it at pi by 2, so what would be the value? So at pi by 2, it will become 1, but this would become how much? What would be the value of this function? Yes, what would be the value of this function? So this would be again sine 2 into 90, sine 180. This is becoming 0, right?
Yeah.
And yeah, so this is becoming 0, and then you have so you see that this pi by 4 is the value where it is going maximum, And then if I write it, so this is 0 pi by 4, then pi by 2, and then what would be the next value that it would become here 0, and then this is pi by 4, and then I add pi by 2, and then pi by 2 plus pi by 4. How much is this thing? This would be 8, right? This would be 4, and this is 2. So this is pi plus pi. So 3 pi by 4, right? So at 3 pi by 4, how much is this thing? So this would be something, right? Yeah, we don't know what would be that thing. But what would be this thing? At 3 pi by 4, this is 2 into 3 pi by 4. So this is sine 3 pi by 2. And what is sine 3 pi by 2? That is minus 1, right? So this would become minus 1. And what about this sine 3 by 4? What is this value? So this would be, if we calculate, right? If we calculate this thing, this is sine of 3 pi by 4, which is sine of pi minus pi by 4. So this is sine of pi by 4. So that would be again 1, right? So this would be how much? This would be pi minus pi by 4, sine 180 degree. That would be sine pi by 4, so 1 by 4. So this would be the value. So now we know all these values. So let us draw the graphs. What would be the graph? If we plot this graph, then what would be the behavior? So one period, we will write the period of 0, pi by 4, pi by 2, 3 pi by 4. And sine function we already know, right? So sine function is goes from, let's say, this is pi by 2, this is pi, this is 3 pi by 2, and then this is pi. So if I plot this sine function, this is 1 and minus 1. So if I plot sine function, so how the behavior of sine function goes? So this goes from pi by 2, 1, then 0, and then at 3 pi by 2 it goes minus 1, and then again it goes 0. So this is the behavior of sine function, right? What is the period? The period is 2 pi. Is it clear, guys?
Yes, sir.
Now if I draw this sine 2 theta function, right? So for 2 theta, I have to draw another angle. What would be those angles? So the angles are multiples of what? Can you guys tell me? What are the multiples? Can you guys tell me that? These are the multiples. Pi by 4.
3 pi by 4.
Yeah, so pi by 4. So one would be pi by 4. The other one is pi by 2. And then we have 3 pi by 4. And then we have this pi. So the difference is pi by 4, 45. 45 degree, 45 degree, 45 degree, and 45 degree. So that is how this function goes, sine 2 theta. So this is becoming 1 at here. Sine 2 theta is becoming 1 at here. Then at pi by 2, it is becoming 0. And then at 3 pi by 4, it is becoming negative 1. And at pi, it is becoming 1. So this is how it right. So this would be whatever pi plus pi by 4. So whatever is that this value is. Right. So you guys can tell me that what is the period of this function? What is the period of this function, guys? Can you tell me? What is the period of this function? When it is repeating, orange one, when it is repeating,
At pi by uh, 2, and then pi, and then 3 pi by 2, and then 2 pi.
so when it is repeating its exact same structure. So you see that for the sine function, this was the repetition. So at this point, it repeated the same thing at 2 pi. Clear? At 2 pi, it repeated the same thing. So for sine theta, the period was 2 pi. Now you identify that for 2 theta, when the whole circle or revolution is done, when the whole revolution is done for the case of sine 2 theta, you guys have that answer in the graph. When it is completing one revolution,
At pi by 4.
so you see that this sine theta is going 1 and then 0 and then minus 1 and then 0. So one cycle is completed at 2 pi for sine function. Now let us see for the sine 2 theta. So this is going 1 and 0 and minus 1 and 0. So when it is repeating itself
Pi at pi.
at pi, so the period of this function would be how much? Is it clear?
Pi. Yes, sir.
So you see that when you multiply a constant beside the angle, then its period changes. So if you multiply a constant beside the angle, then its period changes, but the amplitude, right? So you see that the highest point remains the same. So the amplitude doesn't change if you multiply the coefficient in the angle. But if you multiply a constant in here, then this amplitude changes, but the period remains the same. So for if we multiply a constant before the function, then it will not change the period and it will only change the amplitude. But if we multiply in the angle, right? If you multiply some constant in the angle, then its period will change. So its period would be pi. And how do we calculate that? Let's say if we don't want to draw the graph, right? And I give you this function, sine 4 theta. So then if I ask you that what would be the period, right? So then to the trick to calculate the period of this function is that we compare this whole angle because we know that this whole angle has how much period? What is the period of this whole angle?
At
Pi,
2 pi. Yeah.
right? So then we can calculate the period of this angle that would be 2 pi by 4. So that would be how much? That would be pi by 2. Right, so this would be the period of this. So we can see from this example that 2 theta, and we compare this 2 theta with the whole period. So then we'll get the period as 2 pi by 2, which was the period. So theta equals to pi. Right, so did you guys understand this part?
Yes, sir.
And similarly, same case for cos theta. So again, the period would be pi. This would be the period. And for the case of yeah, cos 4 theta and simply so square, this does not happen for the square, right? Sine square theta and cos square theta, this would have a different period. We can only determine the period if the coefficient is multiplied like this, right? The coefficient should be multiplied for the period. We have to change this sine square theta in the form of this and cos square theta in the form of this, then we can see Otherwise, we cannot say about the periods of these kind of functions, right? We have to change this function in the form of sine theta, cos theta, and so on. So the integral multiple of the p. Okay, is it clear? Is it clear, guys?
Yes, sir.
And again, in the NCRT, I found this very beautiful question. So let me share that. That they had given yeah, with that question, they had given. So in the NCRT, we have this question that what would be the period of this this is still English, right? Okay, so let me just finish. So in the NCRT, they have given. Can you guys hear me? Yes, can you guys hear me?
So your voice is breaking.
Yes, hello guys. When I was taking the other class, then it didn't happen. But for this class only,
So it's
okay.
it
Can you guys
was
hear me
it
now
was
properly?
clear
Okay,
until now,
clear
but
now.
yeah, now it's fine.
Oh, good. So we have these functions, right? And they will ask you that what would be the time period. Whenever we talk about time, that is so that would be time, right? So we have this. Let me just write this as cos theta, right? Cos theta is omega t sine theta cos theta. Again, my voice is breaking. Okay, so is it? Yeah, is it okay now? Is it okay now, Rishita?
Yes,
Yes,
sir,
is it
it's
okay now?
fine.
Yeah, so sometime it starts breaking a lot. Yeah. Okay, so the period of sine theta, we already know that is 2 pi, right? And period of cos theta, that is how much? That is again 2 pi. So now we have to find out Yeah, so okay. Sorry about that. Whenever we are calculating, can you guys hear me? Why? Can you guys hear me? Hello, guys. Can you hear me?
Yes, sir.
Yes, guys. Can you hear me? Yeah. So the next question is what? Next question is sine omega. Yeah. Okay. I'm not got right. Okay. So we have this function. Can you hear me, Rishita? Can you hear me? Sorry about this
Yes, sir. Yes, I
technical
can hear.
right. Yeah. So you see that we have three functions. And what is the time period of this function? Can you tell me what is the time period of this function? Not the time period, only the period. What is the period of this function? Yes,
2
guys.
pi.
Pi. And what is the period of this function? That we have already seen, right? What is the period of this function? Just remember, how do we calculate? We just write, compare it with 2 pi, and then we calculate. So that would be the period. So this would be pi. And the period of this function, that would be how much? Again, we compare 4 theta with 2 pi. So we will get 2 pi by 4, which is pi by 2. Right. So these are the periods of these three functions. Then how do we calculate the time period? So we calculate the time period as LCM of these functions. Right. So LCM of these functions that we have to calculate. So what would be the LCM of this thing? LCM of 2 pi, pi, and pi by 2. What is the LCM? Yeah, what
2.
is the LCM? LCM of 2 pi is what?
The whole thing,
Yeah, the LCM of
LCM will be 2 pi.
the fractional number, right? So we have to be very careful because this is a fractional number. So how do we calculate the LCM of a fractional number, right? So LCM of a fractional number is LCM of fractional number is LCM of numerator and HCF of denominator. That is how we calculate the LCM of a fraction, right? So how do we calculate the fraction of LCM of 3 by 4 and 8 by 60? right? So to do that, we have to remember this. LCM of fraction is LCM of numerator and HCF of denominator. So can you guys tell me what would be the LCM of numerator, which is the LCM of 2 pi, pi, and pi? What would be that? That would be 2 pi, right? HCF of denominator, that would be how much? That would be 1 and 1 and 2. So HCF would be 1. So then the LCM of this thing, that would be how much? That would be 2 pi by 1, so that would be 2 pi. So this is the period that we will get pi. And time period would be how much? That would be 2 pi by omega. Is it clear, guys? Is it clear?
Yes, sir.
So I will give you guys some homework that yes, you have to calculate time period of calculate period and time period of let's say y is sine 3 theta plus cos 4 theta plus sine uh, let's say 2 theta. So you have to calculate the time period of this function. Okay, is it? Then you guys please note down this part. Quickly note down this part, and then we will talk about note down from here. Then we will talk about the simple harmonic function, and I will quickly talk about all things which you guys need. So quickly note it down, guys. Okay, so Amna got disconnected, right? Did she? Yes. Okay, Amna has joined back. So Anders, remember this. Whenever the coefficient or number is multiplied before the function, then period will not change. But if we multiply the number with the angle, then the period will change. So that is what we have to be careful. And if we have combination of different functions, trigonometric functions, then we take the LCM of the individual periods. So that is how we can. Okay, whenever you guys want me to scroll down, please tell. Oh, who got disconnected? So I guess the same thing is happening as well, right? Rishita? Yeah, whenever you guys have noted it down, please tell. Yes, noted, Rishita. Quickly note it down. We have covered so many things. Noted, Rishita. And Amna, yes, guys, noted.
Yes, sir, done. Yes, sir.
Then please note down this part. And remember this very important result that LCM of fraction number is what? Right. LCM of fraction, that is would be LCM of numerator divided by HCF of denominator. So always remember denominator. So if you guys have something like find the LCM of 5, 8 and 3, 5, 4, or let's say 6, 5, then you have to use this thing, right? We used this thing because we got a fractional number in 5 by. So that is why. Yes, quickly note it down, and whenever you guys have noted, please tell. Yes, whenever you guys have noted, please tell. Yes, guys, noted.
So can you scroll down?
Up. Okay, so
Down, down.
yeah, there is nothing straight up to this point, guys. Yes, guys, it. Yes, guys, noted. Yes, guys, noted, everyone.
Yes, sir.
Okay. Now let us understand about a simple harmonic function. Right. So what is the simple harmonic function? And remember that these two functions, the periodic and simple harmonic function, these two functions we will use in our subsequent right theories. So first, let us understand about simple harmonic function. So what is the simple harmonic function? If you have, let's say, a function, right, and this is dependent upon x or theta or whatever. And if you differentiate this function two times, right, and then that is proportional to this minus x, then that kind of is the simple harmonic function, right? So these kind of function are called simple. Say that if I choose a function which is sine x, remember what is d by dx of sine x? Yeah, so this network is bad. Sometimes it's, yeah, it was working well until now, and then suddenly it starts. Yeah, do you guys remember the differentiation of trigonometric functions? Do you guys remember that?
Yes, sir.
What is the differentiation of sine x?
Minus sine. No, wait. X raised to minus 1?
That is algebraic function. Forget about algebraic function. This is nx n minus 1 d by dx. So this is algebraic function. Okay, so let me revise that
Oh, it's cos x.
right. Yeah, so it is cosmic. So this is called the simple harmonic function, right? And let us revise these parts for that we have sine x. So differentiation of sine x, that would give us cos x. And if we have cos x, so differentiation of cos x, that would give minus sine x. And if we multiply a constant here, right? So if we have sine of this t, and then you are taking a differentiation with respect to t, right? So this is the differentiation with respect to t, but this omega is multiplied. So then this differentiation, let me write it here that sine of x. So if I take this differentiation, so this would be cos 2x, but multiplied by 2. Similarly, sine omega t differentiation, that would make cos omega t and multiplied by omega. Similarly, if I take d by dt of cos omega t, so that would be again minus sine omega t and multiplied by omega. So these are the basic differentiation results that we have to remember, right? Please remember these things. And integration, yeah, do we need integration? So yeah, we'll see that if we need integration. But remember these parts, right? Okay, so now remembering these things, so let us write that y is sine x. And if we take the differentiation one time, so that would be cos x, right? And again, if we take the differentiation, so d by dx of this differentiation, right? So this would be how much? This is d by dx of cos x. So this is called double differentiation. It is represented by d square y by dx square. So this is double differentiation, meaning that we are doing the differentiation two times. So this, what is the differentiation of cos x? Cos x is minus sin x, right?
Yes,
And
sir.
if we look back, so this was sin x is y. So this is what? This is d square by dx square, and that is minus of y. So did you guys see that if we are differentiating this function, right? So we are getting who's this big y, right? This big y. So we are getting the same function back again. So this kind of function is called a simple harmonic function, right? So this sin x, cos x, all these trigonometric functions, they are simple harmonic functions. So their second derivative gives back the function itself. Is it clear to you guys? Is it clear?
Yes, sir.
Okay, so depending upon these functions, then we define the different kinds of motions. What is periodic motion? When in a motion, the object repeats its path, then it is called a periodic, right? And it is characterized or represented by periodic function that we have understood, right? Periodic function, right? And then we have this. So, what are the example of these periodic functions? So, the planetary motion, right? Planetary motion, planet motion. So, revolution of Earth around the Sun. That is periodic motion, and rotation of Earth around its axis, right? Rotation of Earth around its axis. This is also periodic motion. Motion of satellites, motion of satellites. These are also the example of periodic motion, right? And then we have this oscillatory motion. Oscillatory motion. So it is a kind of periodic motion, kind of periodic motion in which the object moves and flow around the mean position. So this part is very important, right? Around the mean position. This mean position is very important. So this is called the oscillatory motion. And then we have another kind of oscillatory motion which is called a simple harmonic motion. Simple harmonic motion. So it is a special kind of oscillatory motion, right? In which their acts are restoring force, right? And this restoring force, the direction of restoring force is always in the direction of mean position. Right, so this is the direction of the motion, the force is yeah. So the restoring force is proportional to the distance away from the mean position, right? Or the displacement away from the mean position. So if we summarize all these things, right? So in summary, the force would be proportional to the displacement from the mean position. And if we remove this proportionality, so we get kx. So this is the example of SHM, right? And we'll talk about this thing in detail, but before we talk about this, we always, so let's say we have this spring, and this mass is attached to this spring. So this is the mean position of this spring, right? So this is x equals to 0. This is the mean position. Now we are stretching this thing in this direction. So we stretch this thing in here, and we stretch this thing, let's say some x distance. So now this is the position that is there, right? So where will the restoring force will act? Where would be the restoring force? Yes, where would be the restoring force, guys?
In the x, the distance.
So this is the mean position, right? So the restoring force is always directed along the mean position, right? So this would be the restoring force. So this is always in the direction of the mean position, right? Similarly, let's say if I compress this spring, right? If I compress this spring, so let's say I compress it this position. So this much distance from the mean position, this is the mean position, right? And I have compressed this x distance, right? So where would this restoring force will act? In which direction?
Right, sir. Left.
Right. So this is the mean position. Here we have compressed. So this would be right, right? We will correct in the first place. So restoring force always act towards the mean position, right? This mean position is the most crucial thing, right? So always remember that. This mean position is where this displacement is 0, right? So this mean position is x equals to 0. And then if we stretch this, so the restoring force would be leftwards. If we compress it, then restoring force would be right. Are all these things clear to all of you guys? Is it clear?
Yes, sir.
Okay, then please note down these things, and then we will start the main thing, right? So these were just the background that was needed, and now we will understand about the different things, right? So between you guys, who has this math in their subject? You guys have mathematics. Yes, guys
Yes,
are
sir.
you guys have mathematics. Okay, then yeah. So did you guys do this second order differential equation? Did you guys do
Uh,
this?
no, no, sir.
Not right now. Okay, so yeah, maybe yeah, you will do this. Oh, you guys are in your 11th standard, right? So that. Okay, so that you will study in the higher classes. But we'll just write about the results, right? You guys have differentiation integration. Do you guys have that? Differentiation integration, do you guys have, right? If you guys have that, yes, we'll talk about that later. But, yeah. Whenever you guys want me to scroll down, please tell, right? Please tell me whenever you guys want me to scroll. And remember, these are very important. So these things are very important. That whenever, because in our subsequent theory, we will use this. We will use the function as time. Time will be the parameter, right? So sine omega t differentiation would be cos omega t, and then whatever is the coefficient that is multiplied, so that will be multiplied. Yeah, noted, guys. Quickly note it down and then uh, yeah, understand about important things. Yeah, noted, guys. You guys have noted, please tell.
Yes, sir.
Then please, this is the simple harmonic function. Whenever you have a function which repeats itself after second order differentiation, that function is called simple function. Quickly note it down. Whenever you guys have noted, please. Yes, whenever you guys have noted, And this is periodic, so it repeats its path after some period, right? So that period is called the time period. So after each time period, it repeats its path.
Done, sir.
Then please. Yes, done, guys.
Done, sir.
Okay, so we understood that we have, yeah, so we have this simple harmonic motion, right? And this is the force related with the simple harmonic motion. So why we are calling it simple harmonic motion, right? So how this x is the displacement, right? So x is the displacement, and we have got what is yeah. So we have this f which is minus of kx, right? And how do we write from Newton's second law? What is this force? How do we write the force? How do we write this force? Second law, that is ma, right? And this is minus k x. And how do we write the acceleration? If you guys remember, how do we write the acceleration? So we have this distance or displacement. We take one derivative. This gives us what? Velocity. If we take another derivative, so then it gives us the acceleration. So we take two derivative of this thing, right? This will give the acceleration. So I can write acceleration as a double derivative of this displacement, and that is minus k. And t square, if I take this m the other side, that would be how much? Minus k by m, and this is x. So this would be how much? This would be t square x dt square, and that is proportional to minus x because k and m, they are constants, right? This is the spring factor that we have, or a spring constant. So you guys see that what this behavior shows. This is for what kind of function? What function mimics this thing? What kind of function? So this is a simple harmonic function, right? T square y dx square, that is proportional to minus y. So in here your y is x. So this is proportional to minus y. So this is proportional to minus x. So this is simple harmonic function, right? Is it clear, guys? This is the example of simple harmonic function, which shows that this is the simple harmonic function, right? And how do we solve this thing? So we take this part, yeah, this part I just written. Now let us write this thing. So d square x by dt square, and this k by m is called omega square, right? This is called omega square. And if I take this thing in this left hand side, this becomes the second order differential equation. And this is what I was asking, right? So the solution of this equation, yeah, so that gives you the solution of this equation is x equals to a cos, or we can also write sine. So let me write sine first. Sine omega t plus phi naught. So this is the solution. So this is second order differential equation, and the solution of this equation is this value of x would be this. This is the displacement from mean position, right? This is the amplitude of SHM, or we can write the value of extreme position, right? And this omega is the angular frequency of SHM. This t is the function of time, right? And this phi naught is called the initial angle, or initial position. So that describes the initial angle of oscillation, or SHM, or this is called initial condition, right? And this whole thing is called the phase of SHM, right? So initial angle of SHM at t equals to 0. This is very important. Fine, right? So this is the function, and we can also write this function as we can also use this function a cos omega t plus phi. Both are equal, right? We can use both, and we'll see that, yeah, so we'll use only this one. So our case, we will only use this. So you guys please note it down, and then we'll talk about the then we will talk about this initial condition, right? So you guys please down from of this. Yeah, quickly note it down, and then we will talk about the mean position and extreme position. And after that, we'll talk about velocity, acceleration, kinetic energy, potential energy, total energy. All these three, all those things we will calculate. Whenever you guys want me to scroll down, please. Yeah, whenever you guys want me to scroll down, please tell me. Yes, noted, guys. Yes, guys, noted. Should I scroll it down?
Yes, sir.
Guys, have noted. So both of the functions we can use, right? But that will depend upon the initial.
Done, sir.
Done. Okay, so Amna, what about you? Noted.
Yes, sir.
Yeah. So now, how do we calculate this phi norm, right? So how do we calculate this phi norm? Let us understand that, and then we will talk about this. So now you already guys know that displacement is how much? Displacement is simply a sine omega t plus phi. This is the displacement, right? Okay, so now let us talk about how do we calculate this phi. So let's say that we have this displacement, right? We have this spring, and this is the mean position, right? So this mean position is 0, and at t equal to 0, the object is at this mean position, right? So if the object is starting from mean position, right, then what would be this phi naught? So let's say x is how much? That is a sine omega t, right? So a sine omega t plus phi, and we know this condition, right? Use this condition. So if we use this condition, using that at t equal to 0, x is 0. What is this value at t equal to 0? At t equals to 0, this is 0, right? This is 0, and a sine, and t is 0 we have taken. So this is 0 plus phi naught, right? So a we can take the other side. So sine of phi naught, this is coming to be 0, and which means that sine of the function is 0. So when that happens, at what angle sine phi is 0? Yes. What is the angle at which this phi naught is 0? So that would be 0, pi, 2 pi, 3 pi, and so on. So these are the values of phi naught if we have this, if the object is starting from this mean position. So let's take that phi naught is 0, right? Phi naught is 0, then this function would become what? So this function would become a sine omega t, right? So always remember that when the object is starting from mean position, right, then x is a sine omega t. Okay, and now let's say the second condition is that the object it is starting from let's say the object was here, but it is starting from the extreme position, right? So this was the object, and now this object is starting from extreme position. So as at x equals to at t equal to 0, right? Extreme position means what? What is the value of x? At extreme position, the value of x is a, right? If you remember the graph of sine theta, so this is called the extreme value, right? And for our case, this is a. So at x equals to a, Right, at x equals to a, this is the extreme position. So the object is starting from extreme position. Is this thing clear to you guys? Why this is x equals to 0? Because we have stretched this thing to the maximum limit, right? Maximum limit.
Yes.
So then your x is at a, because the value, highest value of sine function, that is the coefficient of function that we have already understood, right? So we have understood from the graph that the highest value of the sine function is just the coefficient that is behind it. So if this is sin x, that would be 1. If it is 2 sin x, that would be 2. If it is 3 sin x, that would be 3. And if it is a sin x, right, whatever this angle is, then the extreme would be how much? The extreme value would be some a point, some a. This is what we have to remember. Right? So at extreme position, the displacement would be a. Okay, remembering that, yeah, so this is the condition. Now let us calculate at extreme position. We know that x is a sine omega t plus phi naught. So we know that at t equal to 0, x is a. So we are calculating from extreme position. Right. So at extreme position, what do we have? We have x is a, and this is a, and t is 0. Right. So phi naught. So this would be a by a, right? This a goes in the other side. This is sine phi naught, and then if we cancel this thing out, so sine phi naught, that is how much? That is 1. For what value of phi naught sine is 1? For what value? For what value of phi naught the sine theta is 1? When is sine theta 1, guys?
0.
And when it is sine theta is 0?
90.
At sine 90, this is 1, right?
Sine
Same.
90 is 1 and sine
Yeah,
0 is 0.
yeah. So for cos 0, that is 1, right? So theta is phi naught is pi by 2, right? Then what would be the function that we will use? We have got the value of pi naught, so that would be a sine omega t plus pi by 2, right? And we know that sine 90 plus theta is how much? That is cos theta. This would be a cos. So whenever the object is starting from extreme position, then we will use this function. And when the object is starting from mean position, then we use this function. So this is the only difference. Right. Please, you guys note it down, and then we'll stop it here. And yeah, stop it here. Conditions for five. Right. Please note it down. And yeah, tomorrow we'll try to complete these chapters. Now we have already know the displacement, then we'll try to calculate velocity, acceleration, energies, and then this chapter. Whenever you guys want me to scroll down, please let me. Yeah, whenever you guys want me to speak on this.
Sir, can you scroll?
Remember for mean position, right? Mean position function is right. Function is a sine omega t, and for extreme position, function is a cos omega t. So these are the results that we got.
Done, sir.
Done. Okay, so I give you, oh yes, yes, of course, yeah. Okay, so yeah, Amna, have you also noted down this part? Both of you guys noted.
Yes, sir.
Yes, sir.
Okay, so Allah Hafiz guys, all the best for your practical exams and see you guys at tomorrow. All the best guys.